Hi everyone, welcome back to Array series. Hope you're doing good. This is Mahesh. In this video, we are solving LeetCode problem number 18, which is foursome. So let us look into the statement of the problem. So given an array of nums of n integers, return an array of all unique quadruplets, nums of A, nums of B, nums of C, nums of D, such that A, B, C, D lies in the range 0 and n. Okay. Then A, B, C, D are distinct. So they are not equal. Then nums of A plus nums of B plus nums of C plus nums of D is equivalent to the given target. You may return the answer in any order. Okay. So if you see, they have given few examples. You see the constraints. The length of nums array ranges between 1 and 200. And value in the nums array ranges between minus 10 raised to 9 and 10 raised to 9. And the target also ranges between minus 10 raised to 9 and 10 raised to 9. Okay, with this, let us switch to the editor and try to understand this problem in detail. So basically, they have given this particular nums array. Then what we need to do, we need to find quadruplets. So it means combination of four numbers, which sums up to give our target. So in this one, they will give the target. So we will have to find all the quadruplets. Basically here, the target is 0. So now if you see 1, 0, minus 1, 0. So if we sum it up, so 1, 0, then minus 1 plus 0, then it will give us 0. So this 0 is equivalent to our target, correct, right? So if that is the case, this becomes our one of the quadruplets. Now, if you also see minus 2, 2, 0, 0. Basically, we should always consider four numbers here. So if we consider 0 plus 0 plus minus 2 plus 2, then it will sum up to give 0. So this is again equivalent to our target. So this is our second quadruplet. So we need to find all such quadruplets and we need to return. And one more thing what we need to understand. So there should not be any repeating quadruplets. Basically 1, 0, minus 1, 0 is one quadruplet. Assume we got one more which is 0, 1, 0, minus 1. This is not a unique one because if you sort it again it will be minus 1, 0, 1 and 0. So basically, if you sort this one, this becomes minus 1, 0, 0, and 1. This will also be like minus 1, 0, 0, and 1. So if you see, both are same. So what I'm trying to say, if you sort the quadruplets, so they should not be same. So if such multiple quadruplets exist, then you need to ignore the duplicate ones. So this is one of the constraints, and also you should not consider number multiple times. So you can consider one number only once in the quadruplet, because if you see, you can see minus 2 plus 2. Again, if I consider minus 2 plus 2, it will give us target 0 value. But the thing is, I am using minus 2 and plus 2 twice here. So this should not be the case. So with this, we have also seen the constraints. Now, maybe what you can do, you can pause the video, you can think for possible solution, and then you can come back and you can continue watching this video. So now, before understanding what exactly the interviewer will be expecting, let us discuss about the prerequisite. Basically, this is kind of continuation to threesome problem, which we saw earlier. So I highly recommend you please go back and watch that video first before watching this video. Otherwise, you won't completely get this video. So I will leave that link in the description. Please watch that first and then come back and continue watching this video. With that, now let us try to understand the brute force solution. So what is exactly the brute force? It is somewhat same as the brute force solution what we saw for the threesome problem. So basically we will have to try all the possible combinations, then sort the quadruplet and store it if it is a unique value. So we will do the same thing. So basically what I will do, if you want to find all the possible quadruplets, now what I will do, first let us assume this is my first number, this is my second number, and this is my third number. Now for the fourth number, I can consider any one among the remaining numbers. So first I will take this number, then I will take this number, then I will take this number, and I will try to find the total sum. So if any quadruplet or if any combination of four numbers gives us the target, then what I say, I mean, I got my quadruplet, then I will sort it, then I will try to save that in the quadruplet list. Okay, so now this will be first number, this will be second number, this will be third number. Then fourth number can be this or this or this. But this is one combination. Now first number can be this, second number can be this, third number can be this number, correct, right? Now I move one value next. Okay, then I can try the remaining two numbers one after the other, then I will try to find the quadruplet. That is one combination. Then one number first, second, then third number will be this, and fourth number can be this. This way I can check. Then this is first number, this was my second number earlier. Now I can check this as my second number, correct, right? So this is first, this is second, this is third, and in remaining number anyone can be our fourth number. So basically we are trying to generate all the possible quadruplets. Then we will sum it up. Then if we will check with the target. Okay, if we get the target, then we will sort it and we will take it in our quadruplets list. Okay, so instead of, so basically maybe what we can do, we can quickly look into the pseudo code. Basically we need for loops, basically one for loop, second for loop, then third for loop, and fourth for loop. So this is our first number. So first number, what I did, I started with this number, then I move to this number, then I move to this number. So to the max I can move n minus fourth index till n minus fourth index till here. Why? Because if I move here, then I won't get sufficient numbers after this to get the quadruplet. So I will move only till here. So basically it is till n minus 4, which means less than n minus 3. So I will consider that. So my first number travels from 0 to n minus 3. Correct, right? Now this is our first loop. Next, second loop, if you see, if this was my first number, then my second number always started one index after that. Then it traveled to next index, next index, next index, something like this, correct, right? So now my second number starts from first plus 1, then it iterates until not n. So, and not n minus 1 basically. So it will move until this number. Why? Because after second number, we still need two more numbers. So to the max, it can go up to n minus 3. Correct, right? So it means basically we need to iterate from first plus 1 to till n minus 2 basically. Why 2? Because we need at least two numbers after that. So this is okay. Next, third number will start. So again, if this was first number, this was second number, then this was my third number. Then this third number iterated throughout remaining elements. So now I will start my third number from second plus 1 and it iterates until n minus 1. If you see this value, it is getting reduced by 1 because we need so many number of numbers after that. Then our fourth number, it starts after our third number. So third plus 1 till n. Okay, so basically this is n minus 1. This is less than n minus 1. This is less than n. This is less than n minus 2. And this is less than n minus 3. Okay, so then what I will do, I will find the sum. Then if my sum is equivalent to my target, then what I will do, I will store that. I will check first. I will sort the quadruplet. Then I will check if it is there in the, I mean, if it is unique, then I will store it in quadruplets list. Okay, so this is exactly same as the brute force what we saw for threesome problem. So if you have already watched that, then it is pretty much straightforward. So with this, let me go back to editor and let's try to execute this solution. So now what I will do, I will simply copy the brute force solution that we executed for our threesome problem. Here, what I will do, I will copy this and I will make small modifications. Okay, so I will expand this. We used only 3 loops, right, for the threesome problem. So now we need 4 loops. So I will copy one loop, and now what I will do, this is our first number. It iterates from 0 to n minus 3. Then this is our second number, which starts from first plus 1. Then it should travel till n minus 2. Okay. This is our third number, which starts after second number. So it is second plus 1. And it will travel till third number is less than n minus 1. Then this is our fourth number. So I will say fourth. This should start after our third number, then less than n, fourth plus plus. Now what I will do, I will say I will also need to include nums of fourth number. So this will give us sum of all the 4 numbers. Now I will check. In threesome problem, the target was fixed. It was 0. But now we have a dynamic target. So it can be 0 or it can be something else also. So I will give the target. So if my sum is equivalent to my target, then what I will do, I will copy this number. First here, I will sort all the 4 numbers. Okay. So then this triplets, I will say it is quadruplets. I will copy that. Then this will be our quadruplet. This will be our quadruplet. This will be quadruplet. So basically here I am using set because we want to check the unique quadruplets, right? So in JavaScript, normally what we do, so when we put the value into the set, we simply convert it to string, comma separated string, and then we try to compare if it already exists in the set. So that's what I'm trying to do here. Then I finally added the values to quadruplet. Then we need to add that quadruplet string to set so that the value added will be used later to compare. So with that, I will finally return my quadruplet. So it starts from 0 till n minus 3, n minus 2, n minus 1, n, and we are summing it up. So with this, now what I will do, I will minimize this and I will run the code. Now if you see, it got accepted. Now I will submit, but it will give us TL. Okay, so if you see, we got TL. So now let us see how to improve this. So basically, before proceeding further, now let us also try to find the time complexity. So it is pretty much straightforward, right? So we use 4 for loops. So we use 4 for loops. So our time complexity becomes of order n to the power 4. And also, if you see the space complexity, we use set data structure to store the quadruplets, right? So it is somewhere of order n. It is not exactly n, it will be less than n, but we will consider it as order n. So this is very costly algorithm. So we need to improve this. So how to improve? So if we want to improve, then this O of n raised to 4 should be somewhere get reduced to O of n to the power 3, correct, right? So if that is the case, now since we are using for loops, it is becoming n to the power 4. Now if it has to be n to the power 3, then we should try to reduce one for loop. Okay, so how to do that? So now if you have already watched the threesome video, you have already guessed what will be the answer for this. So now what we know, so our target is equivalent to sum of four numbers, a plus b plus c plus d, correct, right? Now assume in the threesome case what we did, a plus b plus c will give us the target in the threesome problem, correct, right? Now if I know one number, then the other sum of other two numbers will get reduced to some problem, correct, right? To some problem. So now if we apply the same logic, if you know any one number, the remaining numbers gets reduced to threesome problem, correct, right? Threesome problem. So if that is the case, now what we need to do, we need to use the better solution from the threesome problem, and we will try to solve this particular problem. In threesome problem, what we did, we fixed first number, then for the remaining numbers, we iterated over the remaining numbers, we took a hash map, correct, right? We took a hash map, then we try to find the sum of two numbers. So that is basically the target for two sum problem, correct, right? So one number will be fixed and the remaining numbers will use the two sum problems solution to find the remaining two numbers. So now instead of fixing one number, let us fix two numbers here. So this is number one, this is number two. So if we fix two numbers, then for the remaining two numbers, we can apply two sum solution here. So basically we use hash set, this solution is directly derived from the two sum problem. So you can also watch two sum problem to completely understand how we solve the two sum problem. So now I will fix my first number here and this is my second number. So first number will be 1 and second number will be 0. Now what I will do, in the remaining numbers, I will use a hash set. Okay, I will start from -1. So if my first number is 1 and second number is 0, then what is my total target? Total target is 0. Now two sum target becomes the total target, which is 0, minus first number, which is 1, then second number, which is 0. So my two sum target will be -1. So now if we find two numbers which sums up to give -1, then we found quadruplets, correct, right? Those are the four numbers which contribute. So here we also sort all these numbers, so that it becomes easier for us to skip the duplicate numbers. So why to skip? Again, you can watch that in this threesome problem. So now what I will do, I will first sort this entire array, so it becomes -2, -1, 0, 0, then 1 and 2. Okay, so now let's consider this as our hash set. So my first number will be -2. My second number will be -1. So here, okay. Then I will start from this number. Okay. So if first number and second number are this, then this is our target will be 0. Then our two sum target will be 0, this is 0, minus this plus this, which is minus 2 minus 1, so that will be 3. So if we get the combination of two numbers which gives the sum 3, then we found quadruplets. So now what I will do, I will take 0. So I will start here. So for two sum I equal to, so basically this is my third number, I will say this is my third number, so third number is 0. Now for the remaining number, which is the complement of third number, that will be two sum target, which is 3 minus third number 0. So this is our 3, right? Do we have 3 in our hash map? No, right? So if that is not there, then we will simply put 0 and we will proceed with the next number. Again we have 0, so do we want to consider 0? Because we have already processed, so I will skip that. So this is what is called skipping the duplicates. Then I will go to 1, so my third number will be 1 now, so it will be 3 minus 1, so which is 2. Do we have 2 in asset? No, it is not there, right? So now simply I will push 1 and I will proceed to next number. Now if you see, we got third number as 2. If it is 2, then 3 minus 2 will be 1. Do we have 1 in the asset? So yes, it is there, correct, right? So if it is there, then we got the quadruplets, right? So our quadruplets will be, one number will be our first, which is minus 2, and another number will be our second, which is minus 1. Then the third number will be 2 and basically 1. The fourth number will be the complement, which is 1. We normally take complement first and this 2 second, third number second, because it will give the values in the proper order. So now if you see, we found one quadruplet. So if you continue the same way, you will get all the quadruplets. So first what we did, we fixed first number, second number, and then we consider this as our two sum problem and we try to solve it. Next what we will do, we will consider this as first number, this as second number, then we will try to find the solution for two sum problem. Then we will consider this and then we will try in the remaining numbers. Next what we will do, we will consider this as first, this as second, and we will try to find remaining two numbers in this combination. So this way we will try using the Hassett way of two sum problem, and also we can say it is a three sum problem. So basically we can try to convert the four sum problem into three sum problem, and if it comes to three sum problem, then we will try to convert it to two sum problem. So that way we can reduce its time complexity from O of n to the power 4 to O of n to the power. So this is our time complexity for this particular problem. And if you see, we use hash set, correct, right? So our space complexity becomes somewhere of order O of n. Okay, let us try to execute this solution and see. So for this again, since it is a continuation of three sum, so I will simply, what I will do, I will copy the better solution from the three sum problem and use it to solve for some problem. So I will copy this, I will copy this, I will go back to, not the code here, I will go back to the code here, I will expand it, I will simply remove everything, I will paste. Okay, so now I will change it, quadruplets. Okay, I will first sort the numbers, then this is our first loop. So basically now what I will do, I will copy this and I will add one more bracket here. We don't need set for the first iteration, so this becomes our target for threesome, correct, right? Then this will be nums of first, and here the original target will be not 0, it will be a dynamic target, so we will use whatever the target they have given. Then this becomes our second number, but it should start after first number, so I will say it as first plus 1. Then I'll copy this second, so second, so basically this first should iterate from 0 to n minus 3. This will be from 0 to n minus 2. This we know why. Then we will use second here. Then we will have to skip the number. So for that, if it is greater than first plus 1, we will skip it. Then nums of second, if it is equivalent to its previous number, then also we will skip it. Then this particular solution is again a two-sum solution. Then what I will do, I will copy this quadruplets. So now here we get a quadruplet. So that will be first comma nums of second comma complement and the current processing number. Then this will be our quadruplet, and finally we will return our quadruplets. So hopefully this is it. So with this, let us try to run and see. There is one place where I have missed. Yeah, this should be quadruplets. Hopefully I'm not missing any other place. It says wrong answer. It is okay. Let's see why. Because this travels from n minus 3 to 0 to n minus 3, this from n minus 2. Then this should be, this is target to sum. For this one, this becomes the target, so this we missed to update, so mistake, so it should be the second number, not the first number. So it got accepted and I will submit it. There is a wrong answer. We will also need to update this value. It should start from the second plus 1. Okay, with that, let me run that. Accepted, and let me submit it. So our solution got submitted successfully. Okay, so now let us see how to improve this. I will switch to editor. So now again the same story. If you have seen threesome problem, so we want to improve this. For that, what we need to do, instead of using hash set, what we need to do, we want to use two pointer technique. So we want to use two pointer technique. So it is again pretty much straightforward. So if you have watched to some video, we are pretty much clear. So now what I will do, if we use two pointer technique, our time complexity remains O of n cube, okay, but our space complexity, it gets reduced to O of 1 because we won't use the extra hash set. Okay, so that is basically, if you copy this example, So I will paste it here and I will try to explain it for one scenario. Assume this is first number, this is a second number. Let's mark them with some color. So this is my first number and second number. Now what I will do, I will take a left pointer, right pointer. Okay. Then I will try to find two numbers in this set and I will assume these two are my first and second number. So since this is sorted, so now my target is 0, correct, right? Then my to sum target will be this target minus these two numbers. So it is 0 minus of minus 2 minus 1, which becomes minus 3 and it becomes 3. So to sum target will be 3. So I need to find combination of two numbers which will give the sum 3. So now what I will do, I will start with these two numbers. I will find the sum. So my sum will be 0 plus 2. So this is left pointer, this is right pointer. So it will be 0 plus 2. So sum will be 2. Correct, right? If sum is 2, then this is less than our required sum, which is 3. So if that is the case, I need to move the left pointer towards right. So what I will do, I will move this pointer towards right. But again, this is 0, so I don't need to process 0. So I will move to next number. Now if you see, we stop at 1. Now this becomes 1 plus 2, then the sum will be 3. So this is equivalent to what is intended. So if you see, now we got this number as first number, this number as second number, this is third number, and this is fourth number. We got one quadruplet. So in the same way, you fix the first here, then you move the second number to here, then you find two sum in the remaining numbers. Okay, so this way what we can do, we can easily process and we can get the quadruplets. So with that, we will switch to editor. So I will expand it. Again, I will copy the optimal solution from the threesome problem and I will try to solve the foursome problem. So this is our threesome solution. So I will copy this. Okay, then I will remove all these things. So now what I will do, I need another loop which is for the second number and I need to close this loop somewhere here. So first I will do that. I will first format, then my first number starts from 0 and it moves until less than n minus 3. Okay, this is our first sum. Now this will be our target for threesome and 0 I need to change it to target. Okay, and this will skip us the duplicate values. Then this becomes our second number. So first I will change all the instances of second here. Okay, but this should start from first plus 1. Okay, it always starts one number after the first number. Then this is our second number. Again, I will simply paste it. Okay, so this 0 should be first plus 1. Then this 0 should be our two-sum target, not the actual, threesome target. So I will change this to threesome target because I'm trying to reduce from four-sum target to threesome target and threesome target to two-sum target. Okay, then this becomes our second number. This is not the first number. Then here, this is all fine. This is target two sum, which is here. Then this will be nums of first, nums of second, and then nums of left and nums of right. So this one I will again change it to quadruplets. I will copy this. This will be our quadruplet and I will push it to quadruplets list. This will be quadruplet. and this is all fine. Okay, so finally I will have to return my quadruples. So hopefully no mistakes this time, but this should be second plus 1, not first plus 1. Otherwise it will give us wrong answer. Um, so that is it. I will try to run and see. I will minimize it. So it got accepted and I will submit my solution. So if you see, it got accepted successfully, I mean submitted successfully. Okay. So this is the best way to solve such threesome problem or foursome problem. So what we try to do, we basically try to reduce from foursome to threesome, then threesome to twosome. So that way we traced back and we used the twosome problem to solve threesome problem, then threesome problem to solve foursome problem. Okay, so hopefully I was able to make you understand this solution. Please consider subscribing to my channel and also like the video, share this with your friends, and also comment in the video saying you have understood this. Thanks for watching the video.